Lesson 26. We're going to finish our little 3-lesson exploration of radicals by looking at a process that's called rationalizing the denominator. Sure sounds fancy. Basically, it's an extension of the idea of simplifying things. Remember the first lecture we did, 24, was just simplifying radicals. You're looking at a radical, you're trying to simplify it. Well, what's going to be new here is we're going to have these fraction-y forms showing up, and the process of simplifying, it's a little bit longer than it used to be. So the first thing we have to do is we have to define how are we going to know that we're done simplifying. It's going to be done simplifying when it's in something that's called simplified radical form. And what is that? Well, there's 4 parts to it. Any radicals that you have are simplified. And that's what we did in lesson 24. So we've done a lot of that already. Okay, so that's the good news. That's not going to be new. The other thing is any fractions. Ooh, did I say that word? I did. Any fractions are reduced. So, of course, we've reduced fractions before, too. That goes way back. What the heck lesson was that? I don't even know. But anyway, you reduce your fractions. Please reduce your fractions. Cancel factors that are common to the top and the bottom. So anyway, that's old, too. So we've seen that before. Here's another thing you need. And this is the big one for today. No radicals appear in the denominator. If you have radicals in the denominator, like we do here, like we do here, like we do here, like we do here, well, that ain't etiquette. You want to reduce your, not reduce your fraction, you want to simplify your radical form so that there is no radicals in the denominator. And that's the process that's called rationalizing your denominators. We call it rationalizing because square roots tend to be irrational. So if you get rid of the square root, it's rational. And so we've rationalized. So, okay, so no radicals appear in the denominator. That's today. Today's big thing. And the other thing, which is actually kind of the same as 3, but people don't often recognize it as such right away, so trust me on this one, but you don't want fractions. No fractions appear inside of radicals. And we'll see that, and I'll speak more to that a little bit when we encounter it. No fractions appear inside of radicals. If fractions appear inside of radicals, that's just as bad as having a radical in the denominator, just as bad. I'm talking like math etiquette here. Don't do it. Not supposed to, because if you don't, you haven't got to simplified radical form. Okay, so anyway, we need some examples is what we're going to need, right? So removing square roots from the denominator. Here's some nice basic examples. And it goes like this. I see a square root in my denominator. I don't like it. Well, remember adding and subtracting fractions, we had this little thing we could do to get common denominators where you multiply the fraction by 1, except it's not just 1, it's like something over itself. Like you could multiply by 3/3, or you could multiply by 4/4, or you could multiply by 2/2. Multiply top and bottom by the same thing, in other words. We're going to do that here. So watch this trick. You're going to like it. You got a square root of 2 in the denominator. You don't like it? Multiply by 1. That counts as multiplying by 1, right? Because anything over itself is 1. You could literally cancel these and turn it into a 1 if you really wanted to. We don't want to. What we want to do is we want to multiply this fraction out across the top. 1 times square root of 2 is square root of 2. And then across the bottom. Do you remember this old trick from last time? You got the root of something times the root of the same thing, and you just get the 2 out. It's just a 2. And then this is done. This is what we call simplified radical form. We have rationalized the denominator. Two counts as a rationalized denominator. Square root of 2 is an irrational denominator, so we're trying to get rid of that. But I mean, that's cool, right? Look at that. What a nice trick. I like that trick. Want to do it again? Let's do it again. So over here, what do I got? I got a square root of 3x on the bottom. Do I like to have a square root on the bottom? No. Okay, let's do this old trick. Multiply the top and bottom by the same thing. Remember, it means I'm basically multiplying by 1, but I'm doing it in a way that makes things look better. So on the top, 1 times the square root of 3x is the square root of 3x. And on the bottom, we have this thing again. This is what makes it work so nice. The root of 3x times the root of 3x is just 3x. This is fun, right? This is fun. We did 2 in a row. Let's do another one. Can you guess what we have to do here? I got x over the square root of 2x. I don't like square root of 2x. Not in the bottom, I don't. If it was on top, I wouldn't care. But on the bottom, no, we don't want it in the denominator. So you just take whatever that is and you sort of copy-paste, really. You just multiply top and bottom by root 2x. Now here you have to remember a little something about how to multiply these things outsides and insides separately. Remember that idea. And then on the bottom, well, this is that same trick again. I might as well use the same color for the same trick. Root 2x times root 2x is regular 2x. Look good to you? X squared of 2x over 2x. Well, I'm pausing because I want to remind you that there are actually 4 parts to this, right? Any radicals are simplified. Yeah, you can't simplify radical 2x, that's fine. Any fractions are reduced. Hey, wait a minute. We got an x here, we got an x here. That's not a reduced fraction. So we cancel the x's there. So we end up really with, that x cancels, becomes like a 1. This becomes like a 1, right? X becomes, okay. So we end up with just square root of 2x on the top and just a 2 on the bottom. There we go. So remember to always reduce your fractions, always. These 2's, by the way, don't cancel because one of them's a 2, but the other one's not really a 2. It's a square root of 2, right? It's in the square root. So you can't cancel inside and outside like that. It doesn't work. So just leave that as it is. Root 2x over 2. Let's look at the next one. So you've got this x root 7 down the bottom, and remember, we don't like the radical down the bottom. The x doesn't bother us in the least, so we don't have to duplicate the x. All we have to do is get rid of the root 7 part. So multiply up top and bottom by root 7. 1 times root 7 is root 7. That's on top. And on the bottom, notice the reason we did this is because root 7 times root 7 is just 7. So we've got a 7. Just don't forget we got an x there too. So it's going to be a 7x on the bottom. Don't lose any pieces, right? You got to be careful. Don't lose anything. Okay. Now, here's that part, what I was saying earlier about you don't want to have fractions inside either. That would be this 4th thing here, no fractions inside the radicals. Well, that's a fraction inside a radical. Here's why we don't want a fraction inside of a radical. It's because really, this is the same thing as this. Square root of 1/2 is the same as the square root of 1 over the square root of 2. And if you look at it that way, you say, oh, I do have a radical in my denominator now, don't I? It was just kind of sneaky. You know, it was kind of hiding. It was kind of disguised. But this counts as not being done. So if you have a fraction, just break it up into a radical on top of a radical like this. It's the root 1 over the root 2. Now, actually going further, root 1 is just 1, right? What times itself is 1? The answer is 1. So really, I just have 1 over root 2. This is the part where you multiply top and bottom by root 2. Across the top, 1 times root 2 is root 2. Across the bottom, root 2 times root 2 is just 2. So that's what you want. Root 2 over 2, not root 1/2. Here's another one like that. So this root 2/3 thing. Again, it's a fraction inside the radical. So really you want to think of it this way. That it's the same as having a root 2 on top of a root 3. So it ain't done because we've got this radical in the denominator. That's no good. So let's do the old times top and bottom trick. In this case, it's the root 3 that we're trying to get rid of. I don't care about the root 2 at all. That's fine. I don't care. It's up top. Who cares? But on the bottom, no, we don't want root 3 on the bottom. So that's why we're multiplying by this root 3 over 3. And that's going to get us, let's see, on the top, root 2 times root 3 is root 6. Remember, insides multiply. On the bottom, root 3 times root 3 is just 3. And so we're done. Cool. Whoops. Don't do that. Okay, only 2 more on this page. What do you suppose we should do here with this 5 over 2 root 5 thing? Well, we don't like the root 5. That's really the only part we don't like. So we're doing this. What do we get is the question. On the top, we have 5 times the root of 5. That's a multiplication. Make sure that's clear. On the bottom, what do you get when you multiply all this stuff together? Well, the root 5 times the root 5 is just a 5. It's just, don't forget you got this 2 as well. So it's 2 times 5, which is 10. Okay, so the bottom is 2 times 5, which is 10. Again, make sure that you remember to cancel 5s here. You're canceling the 5 that's outside because the 10 is outside as well. You can't cancel the 5 that's inside. That doesn't work. So I've got a 1 times a root 5 is a root 5 on the top, and I've got just a 2 on the bottom, and there's my answer. I don't know, you feel like doing this last one? I'll give you the opportunity to pause and then unpause. Here's what we got to do. It looks horrible, horrendous, right? It looks terrible. But the only thing that really bothers us is having this here, our square root in the denominator. That's the no good. So we can get rid of root 3 by multiplying it by itself. Can you do that? Yeah, so long as you do the same top and bottom, it's completely legal. Oops, I said legal. Okay, so what's this going to get us then? Well, up top you multiply outsides and insides separately. You get a 3 outside times a 1 if you want to think of it that way. And then inside, root 2 times root 3 gives you a root 6. So that's what we got up there. And then on the bottom, again, be careful, because when you multiply these two things together, you just get 3. Don't forget you're also multiplying by 2, right? We got a big string of multiplication here. 2 times root 3 times root 3. That comes out to 2 times 3, which is 6. And you know that you should cancel something, right? So we canceled the 3's, right? 3 goes into 3 once, 3 goes into 6 twice. We've got a root 6 on the top, and that's it. We got a 2 on the bottom, and that's it. Simplified radical form. All of these answers that I have circled, I'm going to scroll up. All of these answers that I have circled have satisfied. The radicals are simplified. The fractions are reduced. There's no radicals in the denominator. There's no fractions inside the radical. Those are the 4 things you need, the 4 criteria. If any of those is not true, it means you're not done monkeying around. You got some more monkeying around to do. Keep simplifying, keep going. Okay, so you like that game? That's a pretty good game. I like that game. A lot of people like that game. Now the thing is, that's only 1 game out of 3. I got to show you 2 more, okay? So this one here, I'll try this in green. You might say, well, we don't like the root 2. This is talking to yourself, right? I don't like the root 2 there. Can I do something like this then? And I'm going to put a double question mark because you can't. Why can't you? Because on the top you'd have 1 times the root of 2. Okay, fine, whatever. On the bottom, notice you have like some distributing to do here. So you'd have, here you'd have 3 times the square root of 2. And then you'd have minus, and the root 2 times the root 2 would be just a 2. But notice, you still got a root on the bottom. That didn't work. Oops. Let's use a pencil, not a marker, please. Boink, 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 boink. No, it didn't work. Let's keep these separate. No, it didn't work. It doesn't work. We need a new trick, folks. We need something else. So let me start over. Oh, maybe I could use this. This would be nice. Start over 1 over 3 minus root 2. Let me show you what the magic trick really is. You go like this. You see that 3 minus root 2? Root 2. Do a 3 plus root 2. Do that, top and bottom. This is called the conjugate. Hence, the word conjugate up here. 3 minus root 2. The conjugate is, notice it's kind of like you copy it, except that we made this minus into a plus. So you change that. So you change the subtraction into an addition. If this were an addition in the first place, we'd change it to subtraction. You just change it to the opposite. So that's what makes it a conjugate. Maybe I'll leave that yellow because that's kind of an important point. Now, just trust me, that's going to work. Watch this. So on the top, you just, well, 1 times anything gives you the same thing, so that's fine. On the bottom, we got FOIL action, right? So you do the 3 times a 3 gets you a 9. Then you do the outside, 3 times square root of 2 gets you plus 3 square roots of 2. Then you do the inside, minus root 2 times 3 gives you minus 3 root 2. And, oops, minus 3 root 2, yep. And then you do these last terms. Minus times plus is minus, and root 2 times root 2 is 2. Okay. So what happens is that, whoops, hey, ho. What happens is that you've got this plus 3 root 2, but you've also got this minus 3 root 2. And so the roots go away. It works! Conjugate, that's the ticket. That's what you want right there. So what do we got here? On the top, we got a 3 plus a root 2. Okay, and on the bottom, we got a 9 minus 2 is a 7, and that's it. 3 plus root 2 over 7. There, no radicals in the denominator. There's no way to cancel anything. There's no fractions inside radicals. We're good. Root 2 can't be simplified. We're good. While we're staring at this, though, let me show you something. You can, remember you can do this, right? You can break this up into 2 fractions if you want. This is a nice little same. I don't care which way you write it. I think people tend to go back and forth. I see a lot of people do it this way, and then later in the book or whatever, they'll do it this way. I don't think it particularly matters, but it's good to realize that they are the same thing and just kind of remember that. Remember, don't write this down, but remember when we add fractions together, right? If we had, I don't know, let's say we had 1/5 plus 2/5, right? What would we do? We would add the 1 and the 2 to get 3/5, right? So look at this way. So if you have a 1 plus a 2 over 5, you can make it a 1 over 5 plus a 2 over 5. You can split the 1 fraction into 2 fractions. That's what I'm saying. So sometimes you'll want to do that. So okay, now we know what the trick is. So let's come over to this one. Now we know what the trick is. So if you've got these 2 terms, like this, 3 minus root 3, you've got these 2 terms in the denominator. What you're going to do is you're going to multiply top and bottom by the where are you going? Where are you going? By the conjugate. The conjugate is 3 plus radical 3. What we did is we took this minus and made it a plus. That's how you get a conjugate. So you're kind of copying it, but not quite. So anyway, you have to do the same thing top and bottom. So 3 plus radical 3 on the top, 3 plus radical 3 on the bottom. You're multiplying by the same thing. What do you get on the top? Little distributing action. 3 times 3 is 9. And then you've got plus 3 times root 3. On the bottom, you got 3 times 3 is 9. And then if you don't mind, I'm just going to kind of go like this. We have plus 3 root 3 there, and then we have minus 3 root 3 there. Those are going to cancel, so I'm not going to write them over there because they're going to cancel. But don't forget, you also have to go minus root 3 times plus root 3. Minus times plus is minus. Root 3 times root 3 is 3. What are we looking at here? I've got a 9 plus a 3 root 3 over a 6. Okay, can I call that reduced? I don't know. Don't you kind of smell a lot of 3s here? Like there's a 3 in the 6, there's a 3 in the 9, there's a 3 right there. Whenever you suspect something's going to cancel, I recommend you actually do what we did over here, which is to break this up into 2 fractions like this. Because if you break it up into two fractions, first of all, you can be very confident. It's like, yeah, I know I can do that. I can do that. But then you can be confident about the next step, which is, okay, 9/6, cancel 3's top and bottom, you get 3/2. 3/6, cancel 3's top and bottom, right? 3 and a 3 once, 3 and a 6 twice. Do it that way. And so we're canceling we can cancel 3's here, and we can cancel 3's here. And actually, you can leave it like that. Like I say, some people leave it like that. Or you can put them back together if you really want. And say, wait, it's common denominator of 2, so I would add across the top and put the whole thing over 2. So whichever, you can circle either one, that's fine. Probably this one's the one I'd write, but whatever. So I guess the shortcut we could have taken is we could have right here, we could have said, 3 goes into 3 once, 3 goes into 6 twice, 3 goes into 3 9 times. And notice we get the 3 plus radical 3 over 2. So it does work pretty good to do it that way. The warning is that, let's say we had 9 plus 2 square roots of 3 over 6. You would not be able to cancel 3's into the 6 and the 9. And the reason you could not is because you're not being fair. You have to be able to cancel the 3 in all 3 of these terms. You got 3 terms, that one, that one, that one. If you can't cancel from everybody, don't cancel from nobody. Or, you know, one of the kids is going to start crying, hey, you didn't cancel me. You know what I mean? So anyway, just be alert to that. Okay, 2 more of these. So this one over here, yeah, I know it looks nasty, but it's not as nasty as it looks. That's a common thing that happens in math. It looks nasty until you just kind of resign yourself and say, okay, I'm gonna do the conjugate thing, and then before you know it, you're like, oh, this is actually working pretty good. So you got 2 terms, so you have to multiply by 2 terms. But make sure you're doing it in a conjugate way. That was a plus, so we use a minus. Okay, so you're multiplying top and bottom. This is foiling that we got on the bottom. This is distributing on the top. And you just got to kind of do that. You got to see what you get. Okay, let's maybe change colors. On the top, distribute. Now we remember how to multiply radical terms together, insides and outsides separately. So 2 on the outside is the only thing on the outside. On the inside is 3 times 11, which is 33. It is what it is. Minus. Now you go this times this. On the outside, 2 times 3 is, on the outside, 2 times 2 is 4. And then root 3 times root 3 is 3. Right? So it's a big string of multiplication. Multiply in any order you want. So 2 times 2 is 4 on the outside. Root 3 times root 3 is 3. So really that's a 12. Maybe I'll just call that a 12. In fact, let's make it look like a 12 by doing it this way so it really looks like a 12. Okay, cool. On the bottom, we got FOIL action. This is going to take a while. Root 11 times root 11 is just 11. See, a lot of roots are going away. That's kind of nice. Now, maybe you'll trust me that these are just going to cancel, so I don't have to write them down. Because root 11 times this is negative 2 roots of 33. But then here, positive 2 root 3 times root 11 is plus 2 roots 33. So the inners and the outers are going to cancel. And then you're going to be left with this. You have to multiply these last terms together. So it's positive times minus is minus. 2 times 2 is 4. And what do we got there? We got, well, we'd have a root 3 times a root 3 is a 3. So actually, we got a 4 times 3. We got a 12 again. Allow me to replace that with a 12 here, please. Okay, now, that's looking a little better, ain't it? Now here's the deal. You will not cancel those 12s, because that goes back to what I was saying. Back here someplace, wherever it was, where I said you have to cancel everywhere or nowhere. You've got 1, 2, 3, 4 parts to this thing. You can only cancel if there's something that you could cancel here and here and here and here. If you can't cancel in all places in the fraction, don't. You can't. It's not legal. Don't do it. So don't cancel those 12s. That's what I'm trying to say. So if you're not going to cancel, then you just kind of say, well, what if let me simplify a little bit more. So 11 minus 12, well, that would be a negative 1 on the bottom. And all I want to say here is this ain't done. Okay, please don't leave answers like that. Negative 1 on the bottom. Phew, that looks horrible, doesn't it? No, because we know how to fix this. Remember the idea, you can split this up into two separate fractions. Put the first thing over the negative 1, put the second thing over the negative 1. And then you can basically just do this. 2 radical 33 divided by negative 1 is going to be negative 2 radical 33 minus, and then 12 divided by negative 1 is actually a negative 12, and really that means I have negative 2 radical 33 plus 12. Or if you want to, I'm happy with that. If you want, you can use the more standard way of writing it, which looks, put the number first, put the radical term second. This would be even better. This is okay, but this is like really okay. Okay. One more of these, right? Here we go. I think you really should stop the tape and try that. Why do I keep saying tape? I must be old. Anyway, try that one yourself. Okay, ready? It's all about the conjugates, right? You got two terms here, you have to use a conjugate. So not 2 plus radical 6, but 2 minus radical 6. Multiply top and bottom by the same thing. That's what makes it legal. And then start multiplying out. So what do I got here? Root 2 times 2. Outsides and insides separately. That's a 2 root 2. Root 2 times a root 6 is going to be a root 12. On the bottom, 2 times 2 is 4. And we know what's going to happen next, right? If you use the conjugate, this is guaranteed. I'd have a negative 2 root 6 there, and then I'd have a positive 2 root 6 there, and they would just cancel. So you know what? I'm not going to clutter up my thing with that. I'm just going to go like this, right? And maybe I'll remind myself, outer, inner, cancel. Just to remind myself that I am kind of foiling. I'm not doing anything weird here, but the outers and the inners, well, they cancel. So to do these last terms, root 6 times negative root 6 is a minus. Root 6 times root 6 is 6. Okay, here we are. So we're looking at this now. Now, one thing that's got to catch your eye is that radical 12. That ain't simplified. We're going to have to simplify that. So pull over. Let's simplify radical 12. We can do the tree method here. That's a 2 times 6, right? The 6 is a 2 times 3. And so we got a pair of 2's, which will come out, and we got a 3 left inside. So that's actually a 2 radical 3. So what we got then, so we got 2 radical 2 minus, and the root 12 is becoming 2 radical 3. On top of 4 take away 6 is a negative 2. So maybe what I'll do is I'll do what I've been doing, which is to break this up into 2 separate fractions. So they both get a negative 2 on the bottom. Here the 2's cancel to a negative 1, so I got just negative root 2 there. Here I've got minus, and then the 2's will cancel to a negative 1 again. And the minus times the minus is a plus, and so that's all you get for this one. Negative root 2 plus root 3. Cool, and that's our second game. So the first game was back on page 1. If we just had a single square root on the bottom, you could just multiply by root over root. On the second page, we had 2 terms, so we had to get a little more involved. We had to use conjugates. Well, what's next? Oh yeah, cube roots. Yeah, we're going to have some cube roots to do. It's a good time to take a sip. Having sipped, let's look at the cube roots. Okay, I'm going to do this again. What we did on the first page is we said, oh, just multiply top and bottom by the same thing, right? And since I see this so often, I'm going to actually get this on paper, but I'm going to put double question marks because it's not going to work. On the top, you have the cube root of x, and then what would happen if you multiplied the cube root of x times the cube root of x? Well, you would multiply the insides together, x times x, and get x squared. Well, make that look like an x squared. That would be a good idea. There. Well, the cube root of x squared, that doesn't simplify to just x. It doesn't work. Another one of these double exclamation point. No, it doesn't work. We need a new plan. We need another plan. So here's why it didn't work. It didn't work because of right there. You take a cube root of x squared, you don't get x. Earlier, we were doing root something times root something, and we knew it was just something. But here it doesn't work so well. So what you need, let me see what I wrote down earlier. Okay. Big red ink. Get out your red marker and write this one down. We need x cubed inside the cube root so that the cube root of x cubed does simplify to just x, okay? So the only way you're going to get rid of a cube root in your radical, cube root radical in your denominator, the only way you're going to get rid of that is if it has a cube inside of it, right? If you have a cube inside of it, then you can get rid of the cube root. The cube root of x cubed is x. But if you don't have a cube inside of it, you're not going to be able to get rid of it. And the whole aim is to get rid of it. So you have to build a cube inside. So I'm going to say i.e. build cubes inside. Cube meaning, again, exponent of 3. So start over. Okay, so we got 1 over the cube root of x. That's what we had. I want to build a cube inside. Well, that means I need to multiply the x times x squared. That's how you get x cubed. X times what is x cubed? You have to multiply by x squared. Okay? So this is très important, which I am terrible at French. Very important. Got to make sure you remember this. So you have to build a cube inside. So what I have is 1 times the cube root of x squared is that. And then I've got cube root of x times cube root of x squared is cube root of x cubed, and that's what I wanted. The top is what it is, but the bottom, the cube root cancels the cube to give me just an x. That's how you got to play this game. So it's very important to keep that in mind. If you got a cube root in the bottom, it's a slightly different ball game. You have to build a cube inside. You have to. Let's look back at this one. Over at this one. I've already got x squared. What I need is x cubed. Well, what do you have to multiply x squared by to get x cubed? Just x. And so that's what I need to multiply top and bottom by, is just cube root of x. On the top, I have cube root of x. On the bottom, when you multiply these two things together, you multiply the insides, right? X squared times x is x cubed. And that's the situation you wanted, is you have a cube inside of a cube root, because that will simplify to just an x on the bottom. So the top has a cube root of x, that's still there, but the bottom is just an x. That's how you rationalize a cube root denominator. These next two examples are actually very similar. What we got here is we got numbers instead of x's, but you can kind of play the same exponent game if you want. You need to build a cube. Build a 2 cubed inside. Before we had an x, we wanted to make an x cubed. Here we have a 2, we want to make a 2 cubed. So you have to multiply by 2 squared. So on the top we'll have the cube root of 2 squared. And on the bottom we'll have the cube root of, remember you're multiplying the insides together. 2 times 2 squared will give you a 2 cubed, like this. And the whole reason we like this is because the cube root will cancel the cube exponent to give you just a 2. on the bottom. Just a 2. That's the magic. So what we got on the top, we just got the cube root of, and you might as well call the 2 squared a 4, right? Might as well. We be done. Okay, let's take another look at, that one. Cube root of 4. Well, if you're going fast, you might say, well, I need to make the 4 into a 4 cubed. So I'll multiply by cube root of 4 squared. Yeah, you could do that. But I want to show you something easier. And that's to recognize, hey, 4, that breaks up as 2 times 2. So it's already a 2 squared. See, we've already got some square action in here. So we don't have to multiply top and bottom by 4 squared. We just have to multiply top and bottom by a single 2 inside the cube root. Right? Because the 2 squared times a 2 will give me a 2 cubed. This will give me the cube root of 2 cubed, which is 2. So you get a 2 on the bottom, get a cube root of 2 on the top. Okay, so keep your eye out for shortcuts like that. If you see like a 4 or a 9 or a, what else would we have? Like 4 times 4. If you see a 16 or if you see a 25 or something, you might want to say, well, wait a minute, that 25 is a 5 squared, so all I really need is one more 5. If you don't do it that way, if instead you did it this way, well, it's going to work. The bottom, you have 4 times 4 squared is 4 cubed, and the cube root will cancel the cube to give you just a 4. But on the top, you're going to have a 4 squared is 16 in the middle, in the radical, and that's going to have to get simplified. You're going to have to tree out the 6. Simplify. You're going to have to tree out the 16 and simplify the radical. So it would work, but this is kind of the more direct route, is to recognize, hey, wait a minute, I got a 2 squared already. Okay. Now, this is one that I think you should try yourself right now, but I'll give you a little hint. Start to tree it out. Start to simplify that thing first, kind of like I did here. Simplify that first, then worry about what you're going to multiply by, top and bottom. Okay, you ready? First, I'm going to simplify. And my habit is to break this up as the 9 and the x to the 4th separately, because there's different games you play with the 9 and there's different game you play with the x, right? So the 9, you just tree it out, and that's all you're going to get is 3 times 3. So it's useful, though, to call that a 3 squared. Over here, you'd have the x to the 4th. If you do the hedgerow, you got 4 of these things, right? 3 of them lets you release one outside because the cube root of x cubed is x. So you can basically release an x to the outside, and then you'd still have an x left inside. So what we've got then is we've got an x on the outside, and on the inside, we've got a 3 squared times an x. So I think I'm running out of paper. Well, no, I got more paper. Look at me. I got good paper. So put this back together then. We already did. Put this back together then. We already did. Now we have to remember where we were. We actually had 1 over that. So the actual problem we're doing is 1 over x cube root of 3 squared x. Okay, cool. So what is it we need to multiply by? Cube root of something over cube root of something. We can write that part down. I need to turn 3 squared into a 3 cubed. Multiply it by 3. I need to turn x into an x cubed. So I have to multiply it by x squared. Your goal, this is your whole goal, is to get to a 3 cubed x cubed inside. Some people like to write this first because it helps them figure out what to write over here. But your goal is to get cubes inside. That's your goal. Get cubes inside. You're not starting with cubes, you're starting with something else. So you have to build them up into cubes. That's how you figure out what to multiply by, build them up into cubes. So it turns out we're going to need a 3x squared. You have to do the same thing, top and bottom. So on the top, oh, by the way, let's not forget the x here. So on the top we have cube root of 3x squared. 1 times this is this. On the bottom we had the x on the outside, and then we have all these cubes on the inside. So the top is a cube root of 3x squared. Okay, fine. The bottom is an x times, and this is the whole reason we get the cubes inside, because the cube root cancels them, and we will have just a 3x here. So the answer, it turns out, is a cube root of a 3x squared on the top, and a 3x times an x is a 3x squared on the bottom. And there's your final answer right there. All nice and simplified radical form. Remember, simplified radical form. The radical is simplified. Yep, can't simplify that any further. There's no radical in the denominator. Nope. There's no reducing to do of the fraction, right? You can't cancel this 3 into this 3 because one of them's in a cube root and one of them isn't. So there's no canceling to be done. We don't have a fraction inside of a radical. That's all 4 criteria. We're good. That's done. Okay, leaving us with one more problem. Okay. See, the thing is I have to write so big. I think what I have to do is something like, I wonder if I could do this. Take all of this. What are you doing to me? Right? Okay, take all of this stuff. Oh, for heaven's sakes. I was going to just move it to another spot, but you know what? I'm just going to delete it the heck out of the way, because you could always hit rewind to look at it again, right? You could always hit rewind to look at it again. There. Because what we need to focus on is just a problem. I don't know, you saw me do this one. Maybe you should tackle that one yourself. That'd be a good learning opportunity. Remember I was saying in the previous video about how, you have to, you can't just watch, you can't watch TV and learn how to do this. You have to have the pencil in your hand, and you have to be engaged as much as you can. So the first thing I'm noticing is we should simplify first. That exponent's too big. 16 looks too big. So I'm going to split it apart into 2 pieces. I'm going to deal with the cube root of 16 separately from the cube root of x to the 8th in order to simplify this. To simplify the 16, we should tree it out. 16 is 4 times 4. This 4 becomes 2 times 2. This 4 becomes 2 times 2. And so what we got then, remember for a cube root, we need to have 3 of a kind. And I got 3 of a kind right there. So that will release a 2 to the outside. And then this 2 is still stuck inside. So that's what that is. Now over here, what you might want to do is hedgerow. Remember, 3 at a time. You can take 3 x's and release 1 to the front. You can take 3 x's and release 1 to the front. I got 2 of them released to the front, leaving these 2 inside. So that's how that one simplifies. Okay, now put them back together. Multiplying outside, 2 times this is 2x squared. Multiplying the insides, 2 times x squared again on the inside. And so that's simplifying that radical. Now remember, we had this as a fraction. It was 1 over that. So 1 over 2x squared times the cube root of 2x squared. So after simplifying the radical, you get to here. Now comes the question of how to get rid of that cube root in the bottom. Well, we're going to multiply top and bottom by the cube root of something, right? We need to build to cubes. 2 times what would give me 2 cubed? Well, 2 times 2 squared would give me 2 cubed. X squared times what? X squared times x would give me x cubed. So I'm multiplying the top and the bottom by cube root of 2 squared and an x. So let me get this out of here, and let me show it this way. So this times this is the cube root of a 2 cubed x cubed. You get cubes inside. That means you can simplify it to just a 2x. So multiplying those two big radical terms together will be just a 2x. That's golden. On the top, 1 times this thing is the cube root of 2 squared is 4, really, over x. And then on the bottom, okay, careful here, we need to multiply the 2x. That's what you get from the radicals, but don't forget this part out front. It's also part of the multiplication. So 2x squared times 2x is actually a 4x cubed. And there's nothing to cancel. We're done. There it is. Wow, a little bit of a workout. Hope you're enjoying this stuff. What's going on over there? Hey, go away. I don't need that. That's, sheesh. There we go. We're done. Happy homework, y'all.